The model has finally finished training after 30 minutes, and we can see the amazing speed of this 8-core TPU since we're running our training job on all 8 TPU cores at the same time. We can see that it's taken only about 20 minutes to train RoBERTa base on more than 1 million questions from Quora, and I think that's excellent speed. So as you can see, the training has finished. It says ending training, right? It's finished 2 epochs, and we can see validation F1 score of 0.69, which is actually really good. Anything close about 0.7 is a decent score by the standards of this competition. So okay, cool. So now since we are done with the training process, it's time to visualize that accuracy and F1 score. I mean the cross entropy loss and F1 score as it changes over time, and actually run the inference code so that we can make a submission to the competition. Okay, so first we're going to plot. Okay, this is a binary cross entropy over time. I think the plot does not render properly here in the interactive mode, but as you can see, the cross entropy has plunged to very low levels over the 2 epochs. It goes down to even close to around 0.09 for the validation dataset and 0.084 for the training dataset. And here's the F1 score. As you can see, both of them converge very close to around 0.7 towards the end of the training process. And that's a good sign. It seems like the RoBERTa model is able to actually find patterns in the data and actually predict insincerity with decent accuracy. So now what we're going to do is load up the RoBERTa model and actually make predictions on some sample comments. This is more like the demo section of the project, since we have finished the training process and now we just want to see how it does on certain sample comments. So we're just going to load up RoBERTa base model with all the pre-trained weights that we just generated. Okay, all keys match successfully. That means we've actually loaded up our trained model which we just trained, and this is a function called predict insincerity. All it does is it takes a question as input and it outputs 0. It outputs whether it's sincere or insincere, and basically all it does is it takes a question, tokenizes it, does all the nitty-gritty pre-processing stuff that we need for RoBERTa, and then finally passes it through the model, gets the probability output and presents it as sincere or insincere. So let's just run this here. Okay, okay, looks like it finished running. Now look here, this is a sample comment, right? It says, how can I train RoBERTa based on TPUs? This looks like a sincere question to me, because this is a question someone could actually ask, and the intention of the question is actually to get an answer and not to make a statement. So now it's running RoBERTa base. Okay, so looks like it predicted sincere. Looks like our model is onto something. It's actually able to predict something with some decent understanding of what the text is, and that looks good. And here I just came up with some sort of random question. Why is that stupid man the biggest dictator in the world? Some sort of random nonsense question. You will definitely find these sort of questions on Quora, and they're really irritating, and that's the whole reason why we're doing this project. So if you run it through this model, let's see what it says. Okay, cool. It says insincere, right? So it's worked on a couple of demo questions, and you can actually just spin up this notebook in interactive mode and check and actually run the model on the kind of questions that you want to run it on. You can demo it with any question. It should work fine. Okay, so now let's get down to the actual part where we run inference of our model on the testing data so that we can make predictions to the competition. Remember, we had 375,000 testing samples. Now we're going to run our model on these testing samples and output these predictions as a CSV file so that we can make a submission to the competition, right? So this is the sigmoid function, like I mentioned earlier. It takes the output of the neural network and squashes it into a probability between 0 and 1, right? And this is the inference loop. I'm just going to run it while I explain, right? This is just a nice little progress bar from TQDM, which shows us the progress of the inference process. Okay, so I'm just going to explain what's happening here in this testing loop. So we're just defining test dataset here, right? And test loader, test dataset and test loader. This will help us load the testing data into batches and pass it into RoBERTa base to get our predictions, right? So again here, as you can see, we have with torch.nograd, because we don't want gradients to be calculated during the inference phase. We just want RoBERTa to be making predictions and not its weights being updated through some sort of back propagation. You must have also noticed network.eval set over here. That's because we want dropout disabled for inference, and test spreads equals empty list because we're appending test spreads through the for loop. So for batch and test loader, we're basically iterating through the test loader here to get batches of test data. And you can see test in comma test stat equals batch. And you can see the hyphen here. That's because we're ignoring the target. Remember, we configured our data set to output a bunch of -1s for the testing data when asked for targets. And this is why we are just ignoring the targets here, because we don't need the targets. That's why we're putting a hyphen. Test in and test stat are what we need. So, and then we're moving test in and test stat to the TPU core, right? So that we can perform inference on the TPU. Test spread equals network.forward test in comma test stat. We're basically passing the test input and test attention mask into the neural network to get our output. Test spreads.extend, test spread.squeeze.detach.cpu.numpy. Basically what this does is it takes our test prediction, squeezes it into this single dimensional array, because by default PyTorch, the PyTorch model will output a matrix with one column, but we don't want a two-dimensional tensor, we want a one-dimensional tensor, and that's what squeeze does. Gives us a single vector of predictions, right? And then .detach.cpu.numpy basically moves our prediction tensor from TPU to CPU, right? And then we extend it using test spreads.extend. So this for loop is continuously running. It's iterating through the entire test loader. It's iterating through the entire test data, and it's continuously attaching these predictions that it's making to test spreads, which will ultimately become a submission, right? So we run this for loop, and then at the end here you can see we are basically applying the sigmoid function here, which basically converts our model outputs into probabilities, and then we round it to either 0 or 1, and then np.int32 converts it from float to int. So now what we have at the end is a list called test spreads with a bunch of integers, zeros and ones, and this makes a prediction vector which we're going to output as a CSV file, which we're going to export as a CSV file and submit to the competition. So as you can see, this progress bar is still running. It seems to be close to half done, the inference. Once it's done, we should have this list called test spreads with all our testing predictions for the inference phase, right? Okay, so I think we'll just let the inference code run, and meanwhile I'll explain these pieces of code here below. So these two lines of code, basically what they do is sample submission. So basically sample submission is this submission template which Kaggle gives, which has the correct submission format for this particular competition, and you need to replace the predictions column with your own predictions, because Kaggle puts some random predictions for their sample submission. So these two lines of code loads Kaggle sample submission .csv, and here what we're doing, sample submission .prediction equals test spreads. We are replacing Kaggle's dummy prediction column with our predictions which our model has made, right? So that's what it does. It replaces the prediction column which Kaggle has set and puts our predictions, which are test spreads, right? So once we have test spreads, we just need to visualize sample submission.head. This basically shows us the first few predictions. It will help us see what kind of predictions our model has output, and then this final line of code, sample submission.toCSV submission.csv index equals false. So this basically exports our final submission data frame, which is sample submission, to a CSV file which is called submission.csv, right? And index equals false this is very important, because when pandas exports a data frame to a CSV file, it by default inserts this extra column called index to the data frame, to the CSV file, and we do not want that, because we don't want our data frame to have any unnecessary extra columns or anything like that, and that's why we specify index equals false, so that we only have the ID and the prediction column in our data frame, right? So that this code actually completes the entire procedure from training to inference, and then exporting our predictions made during inference as a CSV file. Okay, so let's get back to this inference loop that's been running here. It looks like it's almost done running. It's, as you can see, there are 46 batches here which is processing. Because our batch size is very big, it's 8192. We have chosen a batch size of 8192 for inference, and so 8192 questions in each batch, and there are 46 such batches in the testing data. So out of those 46 batches, it's done 42, which means it's almost there. Once this progress bar finishes the end and becomes green, that means the inference code has finished running and we have all our testing predictions. Almost there. Looks like it's taking a little extra time on the last batch for some reason. Okay, cool. The inference loop has finished running and we have all our test predictions. Now if we say test spreads, we'll basically see this massive list with zeros and ones, like you can see here, test spreads. It has a bunch of zeros and ones. These are our predictions, right? Load the sample submission, set the predictions, and check the top 10 predictions. So as you can see, our model is predicting a lot of zeros. There's only one in the top 10 predictions, and that makes sense because there are more sincere questions than insincere questions, right? And then export it as a CSV file. So that's it. That's the end-to-end stack of building a RoBERTa fine-tuning pipeline with PyTorch to identify insincere questions, right? And this approach is actually much more efficient and much more performant than CNNs or LSTMs, which aren't pre-trained models. And as an evidence of that, you can see on the leaderboard, if you look at the top team that won the competition, this team got a score of 0.713. And if you look at the RoBERTa based submission which I made using this fine-tuning model in PyTorch, you can see that it got a private leaderboard score of 0.714 with only 2 epochs of training. So you can clearly see that this RoBERTa based pipeline is able to easily outperform models which are not pre-trained, and this really shows the value of pre-trained models. We're able to beat the team that actually won the competition with very little effort and only a little bit of fine-tuning with our already pre-trained language model. So I hope you have finally understood how to use language models on your downstream tasks and actually fine-tune models like BERT and RoBERTa to perform amazing things like this, actually do things like text classification, question answering, etc. And that's it from me. I really hope you enjoyed the video, and like I said earlier, make sure to check out the kernel which has all the code for this particular tutorial, and I will link that code down in the description below. And as always, please like, share and subscribe if you like the video. Cheers.